8 plus 2, 10 plus 6, 16 plus 6, 22. So now all the paths have become the longest paths. So there is a huge change in our network diagram, and all paths have equal number of days. So now it is something very tricky. Okay, so although we have written it, so we will just see c by 10 we will change. Okay, we'll overwrite. I have written all 4x, we cannot do anything, this is fine. G6x, okay, fine. Okay, and D uh, although we have to change, but we are not changing as of now, we'll see. Now since all paths are the longest paths, so again we will try to create the template. Total direct cost is equal to 525 plus something, and the activities crashed, this will be we'll see. Okay, so let's look at this diagram only. Okay, I think this is slightly better. Okay, what is the this we have to crash D, we have to crash C, and out of B and E something has to be crashed. So again let's go back to our this table. Okay, so what are the activities that we need to check? You have to check for B is $40, pretty costly. Okay, B is $40. E is 30. Okay, then D is C is 30, and then D is 25. So in order to achieve the new objective of crashing and completing the project by 1 day, reducing the project duration by 1 day, so we found that the cheapest would be to crash out of B and E. It's E. B is 40, E is 30, so we will crash this. Okay, we will crash E, not B. And also we'll have to crash C, not here, it has to be done here. We have to crash E and C as well as D to reduce the project duration by 1 day. Okay, now since I had written the times, I have remade the diagram, and I have made the blanks. Okay, so it looked like something like this. Now as we are crashing E, okay, we will leave it as 6, and this will be 7. And if we look at the table, we crash E again? Yes, we are in the luxury of crashing E again, that's fine. C, we cannot crash further, so we will just have 9x. Okay, and D also we have the luxury of crashing it by another we used 1 day before, and we are using the second day, so again it will be 9 but not x, because we can still further crash it. Okay, so our longest paths are still the same, but we could achieve the objective of crashing the activity by one more day, and we reduce the project duration by one more day. But how many activities did we crash? E, C and D. E, C and D. Okay, so here we will write activities crashed E, C, D. And what are the cost? Cost for E is 30, cost for C is again 30, cost for D is $25. Okay, so 30 plus 30 plus 25. Now this comes to 610. Now we will plot it here again. 610. What is the cost? 810. Now if we look at this diagram, do we have the option, or can we crash any activity and reduce the project duration to 20 time to 20 days? Is it possible? No, because we have already we already have a path where all the activities are working at its maximum capacity. Okay, 6 has one x here, F has one x here, C has an x here, A has an x here. So even if we reduce E or B, we can reduce the project duration by one more day in this path, but not the one day in this path, but not the entire project duration. Okay, even here D, we can reduce it by one day to and make it 8, but this path still remains the same. So the total project duration cannot be reduced further to anything less than 21 days. So 21 is the maximum number of days in which the minimum number of days in which the project can be completed. Okay, so we started with a graph that is our cost duration, project cost duration graph. Okay, we got this. So now we'll try and make this graph with the help of the numerical that we solved. Here we have the values. Okay, so we'll plot. This is our project cost duration graph. Okay, so we make it again. From this table, look at which is the minimum value here. It is 200 and maximum is 810. Okay, so we'll try to plot like this: 200, 400, 600, 800, and maybe 1000 here. And this is our cost. This is the y-axis, this is the x-axis, and this is our duration. So duration we have 21 to 25, so we'll plot it accordingly. 21, 22, 23, 24, 25, and 26, let's say. Okay, so first we'll plot these indirect costs. Okay, so 21 has 200, 22 has 250, it falls somewhere here. 23 has 300, so it'll be here somewhere. 350 and 400, so something like this. Okay, so this is our indirect cost. And direct costs for 21 days, it is 810. 22 days we have 800 and no, for 22 days it is 775. 775 somewhere here. 23 days it is 795 somewhere again here, and 24 it will be 820. Okay, and the next is 850 somewhere here. Okay, so we get a curve something like this. So which is our optimum cost time point? Obviously this. Okay, optimum cost time point. Okay, and this is our I plotted the total cost first. We need to calculate the direct plot the direct cost as well. This is our total cost, and direct cost is 450, then this is 610. 610 for this. Then we have 525 somewhere here. Okay, then 495 would be somewhere here. Then 470, then 450 somewhere here. Okay, so this is our direct cost. Okay, so the minimum number of days in which the project can be completed is 22 days at the cheapest price. Otherwise, beyond that, if we do it, the cost increases to a very high extent. So best is to complete the project in 22 days. Okay, thank you, class. Hope you will understand and be able to do the rest of the numericals. Please solve the numericals from the book as well. Okay.